Sorry, that got interrupted, and I hope I will be able to connect the two. I got a phone call and that got interrupted. So what I was saying is this, the highest voltage on the board, the way this is being tested is 99.9% safe to say that the board is working good. To be 100% safe, what we need is we need to load the board, meaning we need to actually make current run through it. 99.9% of the time that is not needed. In 1% of the time when the board misbehaves, even though it shows all the proper voltages like it did here, and I did not show all the proper voltages, fair is fair, but it will show them as well if I test them. And the reason I know that is because all those boards, all plasma boards, do have a lot of protections in them because they deal with a lot of power. And whenever a certain voltage is not as it is expected to be, usually the board shuts down. Now sometimes, and this is the 0.01% time when you need to be aware of, sometimes the board may fail when it's loaded. Once a current starts running through it, there are some, let's say, cracked tracks or cracked solder joints, and they may be fine on a standby, but once current starts running, out of a sudden resistor starts raising because the connection has been going through a very, very tiny crack and touching two surfaces merely. The moment current starts rushing in, because of temperature, because of the effect and everything, those may detach or jump, arcing. A lot of different things can happen. Again, this is very rare, but it does happen sometimes. So the best thing to do if you want to double check a board, or not the best thing to do is to test it actually in a live set. And that simply increases your odds to 99.99999 because there can still be intermittent problems that can only show sometimes, but that's another story. Anyhow, it is recommended that the board gets tested with load. And for load here, we're using 150 ohms powerful resistors. We saw this was 207 volts. Let's say that is roughly 1.4 amps. Let's make them 1.25, 1.25. It's easier. 1.25 amps at 207 volts. That's nearly 250 watts, and that's a lot. So those cannot stay connected for a long time. But one way to know that this board is working under load is to have this connected, have the probes on the two ends of the powerful resistor, and then simply connecting the board and seeing whether the voltage goes up when this gets connected. Yep, so that board is currently holding 217 volts through those two. If I disconnect that, the voltage will drop. And I don't know if you saw the spark there. And the spark is because there was a serious current running. So long story short, that board is as it came. Meaning we didn't touch it, we merely tested it. The first thing that we saw when it arrived was that the corners were chipped off. But it's not unusual. It's big and long. It does not affect functionality unless the crack is more serious. Something small like that is just noticeable if you are in the business of shipping those boards back and forth, but it's not really a deal breaker. Nothing else seemed wrong with the board, so that we just ran with the testing as it was, and it just works. And that additionally, the fact that the customer said that there was a smell on the board, around the TV, not on the board. The customer, of course, assumed that the board is bad, well, like they often do. Something got repaired, my TV doesn't work after that, ergo, it failed again. It's I guess, common sense logic, but it's very often wrong from our perspective, from where we see it. So this is just another board that was sent back to us that is fully functional. Whatever burned, my guess, is something on a sustain board. And the reason I am confident about that is this. First of all, we did test it under load, and this is the single highest voltage, highest current power load. There are a lot of watchdogs on the board for smaller, but especially for this big one. And the big one is usually where the problem is. that would have kicked off the board and turned it off if some voltage wasn't in the range that it was expected to be. Of course, there are exceptions from that too, but there are exceptions for everything. That's not the case. If a power board in a plasma TV or a power module like a sustain board starts smelling, usually that's for good. You don't get to turn it on again and see it, working again. Again, there may be exceptions, but the rule is pretty freaking solid. What this tells me is that if that board works here, it never was the thing that was smelling in the first place. It is producing everything, and because it's producing everything, my guess is that a sustain board failed or started to fail, or a buffer board which took down a sustain board or a sustain board by itself. The power surge that this created may have knocked out this board that was here for repair in the first place. And now, once this board is coming and working again, whatever started to fail in the first place and caused the whole shutting down of the TV in a cascade effect of failures, simply burn out completely and ultimately all. It's probably on a sustain board. And again, this one is working. I'm going to send that video. Hopefully this helps you get some idea on how those boards work. There are a lot of things that I did not say, but hopefully you learned something from all that. Thanks for watching and have a great one.